Imagine a hole so deep it could swallow the world's tallest buildings, a vertical tunnel going through ancient rocks reaching depths no human has ever reached. This isn't a sci-fi story, but a real plan from China. In 2021, Chinese President Xi Jinping talked about the need for exploring deep into the earth, pushing for new advances in this area. Why take on such a huge engineering challenge? What secrets might be buried miles below the surface? Today we look into the deepest holes ever drilled and the mysteries they uncover. Last year in May, some of China's top engineers began an incredible mission, digging a hole over 30,000 feet deep. That's incredibly deep, deeper than any ocean and taller than Mount Everest. But there's more. They've also started another project in the Tarim Basin in northwest China. This one will be even deeper, attempting to reach 36,000 feet or about 11,000 meters. If they succeed, these holes will be among the deepest ever dug by humans. China has two primary objectives for its mission. They wish to investigate Earth's past first. Imagine the Earth's crust as a massive book, with each layer representing a chapter in the planet's history. Through probing these strata, researchers hope to reveal the mysteries of our planet's past. There are also business interests. There may be rich energy reserves buried deep within these strata, which might support China's further development. President Xi Jinping launched this deep Earth exploration project in 2021, stressing its importance to China's top scientists. The goal is to reach material that is over 145 million years old. Studying these ancient layers could provide crucial data about Earth's structure and help understand environmental risks such as earthquakes and volcanic eruptions. While this drilling project will be impressive, it won't be the deepest hole ever drilled. That record still belongs to the Russian Kola super deep borehole, which is about 4,000 feet deeper than China's planned depth. Let's examine the Kola super deep borehole, the lowest hole that has ever been bored by mankind, to get a sense of the difficulty of drilling to such extreme depths. This large-scale undertaking got underway in May 1970 and ran until 1994. The reason it took so long was that the crew had to dig 5 different boreholes to get around many mechanical problems. In spite of these obstacles, the Kola borehole produced some exciting findings. As they drilled, scientists found unexpected things like water and hydrogen at deep levels. Around 6,000 meters down, they even discovered tiny plankton fossils. Additionally, they encountered water seeping into deeper layers than previously thought possible. This shows how crucial drilling projects are for understanding Earth's crust, even though the Kola borehole reached an impressive depth that has only just scratched the surface. If future drilling reaches even deeper into the Earth's mantle, it could challenge and change our long-held beliefs. But don't worry, if we do manage to drill that deep, we won't see molten rock shooting up like a volcano. The mantle's rocks do move, but their flow is as slow as fingernail growth. Though we have never seen it up close, the Earth's mantle is a huge layer located deep beneath our feet and an essential component of our planet. Think of Earth like a cake with layers. Our home, the crust, is only a thin layer that makes up 1% of the whole volume of the Earth. The core is composed of 15% iron and nickel. The true heavyweight, however, is the mantle, which makes up 85% of Earth's volume and 68% of its mass. It's composed of solid rock, not molten lava as is commonly believed. But over millions of years, these rocks may move extremely slowly due to the extreme heat and pressure. Think of the mantle like a giant lava lamp without the lava. Near the boundary between the core and the mantle, material heats up, becomes less dense, and rises like bubbles in a lava lamp. It travels toward the crust, flows along the underside, cools down, and then sinks back toward the core. This process is incredibly slow. It can take up to 2 billion years for one full trip from the crust to the core and back. Understanding the mantle is still a major challenge. If we could access it directly, it would be like landing on the moon in terms of scientific discovery. A sample from the mantle would help us understand Earth's origins and how it evolved. But how do scientists know about the mantle without physically reaching it? They use seismic waves from earthquakes to infer the mantle's properties, such as density and viscosity. Additionally, studying how Earth's crust rebounds after an ice sheet melts provides clues about the processes happening below the surface. It's fascinating how much we can learn from these indirect methods. Scientists can figure out what minerals are deep underground by studying Earth's magnetic and gravitational fields. They've even managed to get samples from the mantle without drilling that deep. How? These mantle samples came up to the surface in different ways. Some were blasted out by volcanoes, others came up through tectonic plate movements, and some were found along mid-ocean ridges. However, these samples have been changed by air and seawater, so they're not exactly like the original mantle material. An untouched mantle sample could reveal new details about its density and how it conducts heat and seismic waves. This could either confirm or challenge our current understanding of the Earth's mantle. So why haven't we drilled deeper into the Earth? Attempts have been made, but they haven't been very successful. During the Cold War, there was a race to drill deep, similar to the space race. The United States took the lead with Project Mohole in the late 1950s, aiming to reach the mantle by drilling through the thinner crust of the Pacific Ocean floor. The plan was to start drilling from the ocean floor to reach the crust more easily. The German Continental Deep Drilling Program began its project in Bavaria in 1990, reaching a depth of 29,800 feet, approximately 9,100 meters, after the Soviet Union started drilling on the Kola Peninsula in Russia in 1970. Similar difficulties were encountered by both missions. For example, while the rocket was prepared for launch, they had to develop new technologies to create a rover for the lunar expedition. Costs soared and political issues complicated matters. For example, Project Mohole was canceled 2 years before the moon landing due to rising costs. The Kola Super Deep Borehole also faced setbacks. Drilling stopped in 1992 when temperatures unexpectedly reached 356 degrees Fahrenheit, causing equipment failures and rapid wear on drill bits. The collapse of the Soviet Union further strained the budget, leading to the project's shutdown. Today, the German borehole site has become a tourist attraction, with its equipment still in place. The massive drill rig has been transformed into a crane that lowers instruments for measurement. Meanwhile, the U.S. didn't give up on deep drilling after Project Mohole. It launched the Deep Sea Drilling Project, which ran from 1968 to 1983, significantly advancing our understanding of geology and providing crucial evidence for continental drift and plate tectonics. China has recently entered the scene with plans to drill 2 super deep holes. With substantial financial resources and a timeline of around 15 months, China is positioning itself to achieve major breakthroughs. If successful, they might even attempt to reach the Earth's mantle. These projects, while possibly politically motivated, are primarily about expanding our knowledge of the planet. Each new layer we uncover deepens our understanding. That's it for today. We've explored some of the deepest holes ever drilled and the exciting new projects underway. China's ambitious drilling efforts could reveal amazing insights into our planet and even help us discover new energy sources. If you enjoyed this dive into Earth's mysteries, make sure to like this video and subscribe for more fascinating content. And let us know in the comments, what do you think will be the next big breakthrough in deep drilling? Thanks for watching.